Hello everyone, it's Peter here, Piotr Fissner. How are you doing, guys? Hello. So, in today's episode, we have a power supply from the TV. It's actually my postman's, so I need to do a good job. The power supply have died. What I found is that on the input side there was no beep. Yeah, so that's mean no short on the mains, which is usually a common thing because you get a fuse, and this fuse is usually blown. Now I had to solder 5 amp fuse wire to make it working back again. So now it's working, yes. But then I check, okay, so I won't be checking the inductors here, capacitors. I will go straight away for the bridge rectifier. Okay, so I've checked positive and negative and it was a beep. Now you see there's no beep. Okay, the same on the input side, no beep. So if I see a beep on the positive side, like a plus and minus side, I know that either the bridge rectifier is faulty, or the next MOSFETs are faulty, or there is something else wrong. So what I did is I removed that bridge rectifier, and I've seen further problem with MOSFETs. These MOSFETs I bought on AliExpress because it was 7 days delivery, and it's a F13 and 60 M2s. If somebody don't have them in stock and need them, I have them now. So either book repaironline.co.uk or Inte.Team or Inte.Team Livingston on Google. You can let me know. So what I want to say is I found that one of those two MOSFETs had a short, and these are the MOSFETs. Okay, so I don't remember which pins were out. Let's do the left to the center. Nothing, nothing, nothing. So this one is probably the good one. I replaced them both, you know, I don't like to replace. Oh, here. Okay, so it's on the, I don't know what's left, right, and so on. You would have to check the data sheet, yes, but I know that if you've got middle pin and outer pin in the NPN type of a MOSFET, you get it pretty much short. I removed that and I've checked, and now none of them have any short here, so it's fine. Everything is hunky-dory. Now there's no short as well on the bridge rectifier, and I've checked random diodes, like readings normal, no problem whatsoever, no open loop, yes, and passing current. So everything is okay here. I can't say there is more shorts or anything. And if I will keep minus and can't touch the diodes, I would have short because of course I have the short on the main power. So it's nothing on this side. Now on this side, on the other hand, I didn't check yet. Yes, I didn't check completely. So let's get a random capacitor here. There are a few. Well, on this one won't be because that's a minus and plus. So we would have on the bridge rectifier still short. So we can check those. That's a minus on at the bottom. And here plus, no short. Very good. Now next capacitor here at the top is minus. Nothing. Great. Now here to the right it's minus. Yeah, none of them. And here minus is to the right. Okay, so maybe we can plug it in. And at the bottoms is plus. Ooh, no, it's fine. And these are in series, so no, sorry, in parallel. So one would have short. So I don't see any shorted capacitors. Now that's some inductor. And here are some either double diodes. Yes, double diodes. So left and right, that's a double diode. And then will be passing current. It's like a TO220 packaging, similar to this packaging of the two diodes. That's anodes and cathode inside, yes. So from anodes, yes, it's a diode because I see 0478, yes, 0478. So which is fine. And then the other way around will be probably 0. Yeah, oh well. Yes, so that's good. So that's safe and sound. Now these ones, no, this one is 479 1. Oh, that's not double diode. Yeah, that's not double diode, but it's working okay. And that's double diode? No, doesn't look like. Oh well, maybe single diode. So I don't see shorts on this side. So in that case, yes, what we could do is we could plug it into the power, but I don't want to just plug it in. I will prepare everything and I will be right back. Okay guys, so I've got protective glasses. I've got my in-phase bulb, old-fashioned, old-style bulb. I need my meter now. Back again. Okay. And I will do volts in the DC, and we can observe if nothing will blow into my face, of course, which I doubt, but who knows. Let me go. Oh! Something has popped, and I need to check what it was. That was unexpected to be true. We still have voltage. That's not a lot. 2.4, 1.5, something has popped. There's no forward voltage on the diode. That's disconnected. Okay, so I didn't see that one coming. I will click on the diode mode. It's no shorts, no forward voltage on the diode, regular stuff. So I need to get my glasses. You see? Okay, it's not my soldering job. J-O-B. That's capacitor. That's weird. It's nothing. Like, I've heard pop here, but I don't see anything burned. Nothing burned on this side. 0 ohm resistors are fine. Okay, that's okay, because okay, well, I will risk it again because I don't see a point for something. I don't know why it was the pop noise. Okay, what do we have? Volts, DC. .338 volts, which is nice. 338 volts on the big cap. So I would say okay. Now this is LED connector and that's backlight connector. I mean the main power rail connector. So we need to check now if we've got a voltage on this main connector, like minus. Where is the minus? Okay, that's this line. So in between this, and we need to check here if there is a standby voltage. Stable 8.89 stable voltage. So this power supply is back to life. That's 8 volts as well. That's 8 volts as well. So 8 volts is worrying me. I would expect like 12 volts or something, but 8 8 again, 8, 0, and 0. So the question now is if 8 is enough, and I would say it's not enough because it's showing here 13.2 volts. So something is wrong. Primary driver on, 13 volts. So I will need to see now what is causing the 8 volts. Because I'm not 100% sure why we have 8 volts. Okay, the capacitor losing the charge. It's not 300 anymore, it's 200 something. But on the bridge we should still have, yeah, still 300, so that's fine. I don't expect this to fail. I expect it now to have problem on the secondary cold side rather than on this side. I will find what's wrong because I don't know what's wrong, but the video has 11 minutes, so let's do part 2. Okay, we will see what will be in the part 2. I will switch it off. For those who don't know what is this device, the fuse is in it as additional security in this wire. Okay, and now the phase line, the L live, it's going from this through this to this through the bulb. Okay, live. Whereas the neutral goes straight away from this through the wire, yes, through the wire without a fuse to this connector, and then when you hook up your device, live is going through the bulb. So when something is blowing off, like the fuse, it won't blow off, just the bulb will start to light up. The only secret in it is that you need to have this old style bulb, Wolfram bulb. We call it in Poland, I don't know, I think Wolfram is the same word in English. So when you use this type of bulb, it will work. If you use the LED version, yes, it won't work. But anyways, that's all I wanted to show you in this episode, guys. So thank you for watching. That was homemade, yes, so anybody literally can do it. That's a screw-in bulb. You can buy them on eBay still. I don't know where else, but on eBay I bought them. So guys, thank you. If you don't mind, leave us a like button, and let's see in the next episode, maybe of this one, yes, because I need to know why there's 8 rather than 12 volts now. I will test it and I will let you know in the next episode. Thank you, guys. Oh, if there is no fault and this is working, I will leave pin comment underneath this video, so check if there is pin comment. If there is no pin comment, expect second part for this video. Thank you, guys. Bye bye.